Now let's look at a small example where you have person's income and expense data across 5 months from a list. And the goal is to compute his saving across these 5 months. You might be thinking of doing this manually by going through first element of the two lists, subtracting them and kind of saving the record as the saving for the first month, then go to the second element and then so on and so forth. This may look simple, but if you want to do this across 10 to 20 years, would you do the same? This is where the concept of iteration comes in handy, as you are repeating the same operation over and over. With this in mind, let's start talking about loops and iterations. Loops and iterations are an important topic in Python. Basically, repeated execution of a set of a statement is called iteration. Iteration in Python is implemented using for and while loops. Let's start with a simple while loop example. A while loop starts with the keyword while, followed by an expression. As long as this condition is satisfied, you keep running this loop, and once the condition is not satisfied, you will exit the loop. Okay, let's start with this simple example where we are trying to create a pin checker, which we generally have in our phones or ATMs, right? So you're going to get a pin from the input, enter 4-digit pin, and you are going to have the following, right? So as long as the pin, this is how a while loop would look like. You are going to get a pin from the user for the first time. If the pin is not equal to 1, 2, 3, 4, you are going to get another pin. And because you're going to write invalid input, please try again. Once the user put this input of 1, 2, 3, 4 as the pin, you would exit and you would print validation. Pin validation was successful. Let's run this. So you're going to get one input from the user. This is the first line here. And let me just print something like 2, 3, 4. It would tell me that the input is invalid because it's looking for 1, 2, 3, 4. And he's asking me to try again. Basically, this line of code is now being run. It's getting executed because the first entered pin is not equal to 1, 2, 3, 4. Let me do 5, 6, 7. I'll get the same. So I'm still in the loop. And okay. Now let me do 1, 2, 3, 4. Okay, it is still telling me that this is not equal to 1, 2, 3, 4. Let me do 1, 2, 3, 4. So at this point, it would tell me that I've entered 1, 2, 3, 4. So this condition is no longer satisfied and it would exit the while loop. So this is the very basic iteration loop that we have. We have a condition here. So this part is very much like if statement. So instead of if, we have while. But this is going to be repeated over and over. And it's not like if else that it would be repeated for only one time. This would be repeated as long as the pin is not equal to 1, 2, 3, 4. The moment you enter the pin as 1, 2, 3, 4, this would exit and you would jump to this line of code and the run would be finalized.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
Now, if you want to add a maximum number of tries allowed on condition on the previous example, how should we go for that? So the goal here is just not to go through this loop for infinite number of times, but let's say we have a max attempt count of 3. Here is how we should do it. So we need to import this library, which we will talk about it, but that's in Python definition. We require this for exiting the code and displaying the error. We need to get a pin from the user like the one we had above and do the following. So we start with an attempt count. So we need the counter equal to 1. So this part is very much like above. We will have a while loop which goes over and over until the pin is equal to 1, 2, 3, 4. But at the beginning of each loop, we are checking our counter. And if it's larger than 3, we are going to exit. This is how you would exit a while or a for loop. This is how you exit this loop. So this is basically going to tell you that from this library, I'm going to execute this command method called exit, which is also going to print this for me. If the number of count is larger than 3. So that loop is not going to go forever if you keep inputting a pin not equal to 1, 2, 3, 4. Otherwise, basically, if you don't exit, you're going to get an input from the user, and here's the note here that you have to pay attention. You are going to increase this counter every time you do that. So basically, you're going to go through this for the first time. Attempt count is 1, so this won't be executed. You're going to get another input. Your counter is increased for the second time, and then for the third time, this, no matter what input you give, this line of code will be executed and you will exit this while loop. And finally, you're going to have a print like this. So basically, the moment this happens, nothing else would be executed. You're just exiting the whole code and with this error message. Okay, let's try both scenarios. I'm going to input 2, 3, 4. So I will be entered in this loop. And because attempt count is still less than 3, I can input another thing. I'm going to do this. And then let's say I keep inputting wrong stuff. My attempt count is now 3. So this is going to tell me that because of too many invalid attempts, an exception occurred and we are exiting the code. It looks like an error message in some sense, but you can see that it's a system exit. So you have executed system exit. Let me run this same code on a different block where we do, okay, like let's say you do 2, 3, 4, 4, 6, and eventually you, before the third attempt, you put the right pin, and hence you will get this message, which is this line of code. So this is very similar to the previous code with that extra counter, which is an important technique in while and for loops. In most of these loops, you may need an additional auxiliary counter to do counting for you. Sometimes you would just need that to print it at the end of the code, or sometimes, like this example, this is going to play an important role in your code where you want to exit if the customer has tried his or her third attempt. Now let's look into different type of iterator, which is for loop. For loop is designed for something called counter-driven loops. Counter-driven loops iterate over a fixed set of values. This set of values is provided in form of an iterable object. Iterable objects are things like string, list, tuples, or dictionary. Basically, in counter-driven loops, you are iterating over a list or over a tuple or over a string. Let's try to iterate over a list of integers and get more familiar with the concept of for. So we have this list which we defined like this, and you're now familiar with the list, so you know what I'm doing here. If the goal here is to print all the components in the in the list, one way to do that is just to simply print L. Obviously, we don't want to do that. But let's say we want to print each element one by one. We need the for loop. And this would be counter-driven loops because you are looping through an iterable object, here being the list. So you have to type for element, or var, anything you want to type here, for var in L column, and you come here and you say print var. Okay, let's see how this works. If you run this, it would go through L from the index 0, print the first element, second element, third, fourth, and fifth element. So this is how you loop through a list, or in general, how you loop through an iterable objects, which we call counter-driven loops. Let's try iterating over a string, which is another type of iterable object. So let's say we have a string which we define as New York, and the goal is to print, well, obviously, we know if we do print string, we will get all the string all together. But if you want to print each character at a time, like we did for each integer here, we are going to define a for char in string print char. So we would get new space. We have a space here. That's the space york. So basically, this is again very similar to iterating through a list. Instead, here we just iterate through string, and that's how you iterate. So this is the name of the string or the iterable object, name of the list, and this is just basically each element at the time would be stored in char or var here. If you want to iterate over a string, and after each character, let's say you print a column, right? So you want to print each element of a string, each character in the string, new, but you don't want that to go like the next line. You want them all to printed in one line. Instead, each character is separated by a column, right? So we have to use something called end inside the string. So again, we can kind of copy the same code. So you are going to iterate through the string one character at a time. The only difference here is that you should use something called end, and here put the separator that you have in mind. So basically, if you do not mention anything like you do here, the default value is that it would just go to the next line, right? So that, let me just put the comment here. The default value is n equal to \n, meaning inter. If you want the separation between the lines not to be inter, you can identify that by setting a value as n. Let me just run this. So you get, again, all the characters printed. Instead of separating them by an inter or line break, you get a column. Okay, that's about iterating over a string. We can iterate over a dictionary because dictionary is an iterable object. Let's define a dictionary as follows. So we have a bunch of keys, which are the numbers. It's a simple dictionary. The keys are numbers 1, 2, 3, 4, 5. The values are list of a name and a number, right? So if you let me just print this because this is also interesting. You can see these are the keys and these are the values. So the values are list, and in each of those lists you have a string, name of a person, and a number. Let's see how we would loop through dictionaries. Looping through dictionary is slightly different because here, when you loop through string or list, each component is like a single element, right? You will loop through 1, which is one element, 2, 3. Here you will loop through N, E, W. They're all one element. But when you loop through here, you have actually two elements. You have a key and a value. So the best way to iterate through dictionaries is the following. You have two elements to unpack, right? In the name of the dictionary And then let's see what we have here. So if you do this, you have something called items, like this, parentheses. So this is the best way to iterate over dictionaries. Let me copy this here because we're continuing. This is the technical way and the routine way, standard way of looking through dictionary. For key and value in name of the dictionary dot items, print key and value. When you print this, you get all the keys and followed by the corresponding value, right? Okay. You can specifically iterate through the keys of a dictionary, right? So you can just do for key in student data, and here just click keys, right? So this is, if you just want to loop through keys, which may happen because of the application, you may not be interested in the values, you just loop through key. And you can just print them, that you would get 1, 2, 3, 4, 5. You can also do the same thing for values.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
You can create iterable object using a function called range. Let me just do range. You see the color turned green, so it's one of the standard syntax, and you can do 1, 5. That's why we get range 1, 5. So this is kind of telling the Python interpreter that I want all the items, all the integer numbers between 1 and 5. Right. So you can convert. So this is basically generating a range of values. In order for you to have a tangible data type, you can cast this range to a list. So you can just say L equal list. You're casting the range 1 to 5. If you do that and you print L, you would get a list of numbers 1 to 5, again 1 inclusive, 5 exclusive. So these are 4 elements, and basically, so the range is giving you an iterable objects, but in order to physically be able to access to those or kind of make a tangible data structure, you need to cast it to either a list or a set or a tuple. Here we just cast it to a list. And you can now, obviously, we can loop through the list, but we can also loop through the range itself. So you can just type for in L print. That's one way of looping through that, right? But you can directly loop through the range itself, right? So you can just say 1 to 5. In other words, when I print range from 1 to 5, it doesn't print the values for me. It is telling me that I have a range of numbers from 1 to 5 in this variable, but it doesn't print it. In order for me to see the values, one way for me was to cast it to a list and then print the values of the list. But I can also just loop through the range, because range by itself is an iterable object. So I can just say, print those values for me when you do range, right? And I can just, make it fancier. Say, okay, don't end the line with a break, just make it like a space. So it would print them one in all of the values in one line, separated by a single space. There is also another thing that you can do. You can have different values with the range. You can do other stuff. Let me just have 2 samples here. They're like a fancy sample. Let me just go through this one first. So let's see what we are doing here. We are creating a range of values between 1 to 100, but with the steps of 2. So basically we have 1, 3, 5, right? So there is a step or stride of 2. If I cast it to a list, then I can print it. Otherwise, I have to loop through the range, right? Let's just check this one. So you get 1, 3, 5, and you go up until 99. You can also do the following. You can have a range from in a kind of a descending fashion. You can range from 100 to 0, but now you need negative steps. This is creating the range for you. You can either loop through it the way we showed in block 49, or you can just cast it to a list, print the list up front. This is going from 100 to 1 with increments of 1, kind of with decrements of 1, if you will, in a negative steps. Okay, so far we have introduced while loop and for loops, and we shown examples on how we can iterate through lists, strings, dictionaries, and eventually range, which is one way of creating a set of sequence of numbers or characters. Let us finish this sub-session with an example, kind of a comprehensive one. We want to write a program to print prime numbers between 1 to 20. So you may know that a positive integer greater than 1, which has no factor other than 1 and the number itself, is a prime number. Numbers like 2, 3, 5, and 7 are prime, but 6 is not prime because it has factors like 2 and 3. And the number which is not prime is technically called composite. So the goal here is to write a code to find the prime numbers, print them between the numbers that are between 1 and 20. So we have for n, and we can use range here because we want to go from 1 to 20. Now we have to basically, for each of these numbers, we have to see whether they have a factor other than 1 and the number itself. So basically for each number, for each n, we have to go from 2, let's skip 1, right, because we want to know if there is a factor other than 1 and the number. So for each number, we have to go through the entire range of 2 to 2 until n, and check if n has any factor other than 1 or not. So basically, for each number, you go through this loop. So let's say if your n is, I'm just going by an example. If your n is 7, here you have to go from, then I would be 2, 3, 4, 5, 6, but excluding 7, right? This is just an example of telling you what would happen for, this is the nested for loop. First of all, if I haven't mentioned it, this is the nested for loop. For each fixed value here, you are going from 2 to that value. And if you find a factor, you would just, break, because that's you need to exit this, because this is definitely not a prime number. Then n is not a prime number. You don't want that to be printed. Okay. So one way to, basically, there is no point from this. There is no point to continue this. It's better, it's more efficient to exit the inner for loop. Right? It is better to exit this one. And one way to exit for loop is break. The command break would exit the most closest for loop to that, right? So if you exit here, then you are kind of coming to this line. Now we want to know whether that it's time to check print I or not, right? Okay, so one way to do that is that basically let's define a flag here and set it every time to false or true. And if such a thing happens, change this flag to false. What is the purpose of this flag? By this flag, you would know that if the number has a factor, hence not a prime or not, right? So if you reach this line and flag is true, that means that you have never entered this line of code for that specific n. That means that n is prime. So you want to print it. But if you have ever entered this line, you have exited this for loop, but you are still here, you want to know whether to print I or not, right? So the goal, the ask here is that whether to print I or not. The only way you would know that I is prime or not is by setting a flag. So using flags and flopping them from true to false, false to true is a very common technique in programming languages and in Python as well, where you can check conditions that if something happened or not within a for loop. So first of all, you need a flag to make sure whether you have entered this line of code, and entering this line of code means that n has a factor other than 1 and itself. So definitely this shows that n is not a prime number. You change the flag to false, hence not printing it here. And second, this is the best way to basically use two for loops. The first loop is just looping through 1 to 20. The second loop is just looping from 2 to n. Let's just run this code and see what happens. Okay, interestingly, you have 1, 2, 3, 5, and 7 printed. We know these are prime. 11 is prime, 13 is prime, 17 is prime, and 11. So let's just have a kind of another loop here, just to print n, and then you can have something like is not prime. So you see, for 4, it is telling you that 4 is not prime, and you know what? Let's have also I printed here. That's my way of debugging code, is that it is telling you that 4 is not prime because 2 is a factor of 2. Sorry, because 2 is a factor of 4, because 2 is a factor of 6, or because 3 is a factor of 9. So you can see that the numbers that have a factor of 2 or 3 has been checked as not being prime, and hence the flag to false, and they're not printed as being prime here. This is just a checkpoint for you that what is the reason for those number being not a prime. You can find a factor that shows that, okay, this number is not prime because 2 is a factor of 4. Okay, this is a relatively comprehensive example. I would urge you to go through this example again and again and again to understand the notions, because we are kind of bundling a lot of concepts here. The concept of nested for loops, the concept of checking a condition inside the for loop, the concept of using break to exit a for loop and not to continue. One note here is that there's no need to, once you find that the number is not prime, let's say there is a factor of 2 or a factor of 3, there is no point in checking other factors. So it's efficient to exit this for loop. And there are lots of concepts here. We are using range, we are using Boolean numbers, all of that. So, I mean, this is kind of summarizing what we have learned in one good example. So I would definitely urge you to go through this example, run this for multiple times, put prints wherever you feel there is a need that you want to check a value. This is the best way of debugging a code, is to put prints where you have doubts or questions, or you want to check the counters or what's going on with specific variable. With that said, it's now time to go to our next iterator, which is comprehensions.